On behalf of the Samsung Internet team, I'm very happy to be here. The presentation that we're going to be hearing today, it's called Look Ma No 6 Degrees of Freedom Hands. Good. So yeah, the story that I've been telling, Evergreen browser, new web features, and among these new web features is web expectations that you have from the web, that users have from the web, expectations, on the other hand, that users have from VR. And then VR, the challenges that we have, and the way that we are distributing and doing our experiences today. So there's surely a better open cross-device, different and especially frictionless way of doing this. WebXR definition. I think we've caught up, right? Good. We're on the same page now, I hope. And please, if it freezes again, let me know. So, okay, the specification pretty much is going to describe how the web browser is going to be able to connect to VR devices that are attached to the hardware. Browser support that we have, we can start by Samsung Internet, which is the first mobile browser, consumer-focused mobile browser that had support for the WebVR specification. But nowadays, we're joined with by Firefox, which I believe since version 55 is supporting the specification as well. Chrome for Daydream devices, and if I'm not mistaken, recently they announced Chrome 66 has support for the Oculus Rift, Microsoft Edge and support for Windows mixed reality devices, and the Oculus browser, which has support for both the Samsung Gear VR and for the Oculus Go. Now, if you're thinking about creating a VR experience, then you might be thinking in targeting one of the platforms that we have on the left. So you can just see that independent of the combination of operating system, browser, and headset, you're going to have a right combination that's going to allow you to see the content. Now, it's a bit more trickier depending on feature detection, some things that you want to do, but the benefits of WebVR are gravitating towards discoverability of the experiences that you might create, the reach that you have, the ubiquity and the immediacy in which your users can access these experiences, socialness, and how we are enabling new creators. So let's start with discoverability and see how we can mix and match different technologies to create really engaging and innovative experiences. Let's think about what happens if we combine a physical web beacon with progressive web apps with a WebVR application. This could be used in order to have a beacon broadcasting a URL that can be picked by the phone. You tap on the notification. This opens the browser. You're in a WebVR environment, but you get add to home screen because it's a PWA. So you can add it to the home screen, and you have a VR experience that's right in your home screen. And of course, if you open this home screen, this icon, and you put the phone in a headset, then it could be that in less than 30 seconds, you are going from a physical object to a web browser to a home screen and ending up in a VR. Reach, which is the main focus on this topic. How can we make sure that the users that you're going to be targeting can access the experience in one way or the other? So when we're talking about reach, we want to make sure that even if you're just on a phone, all the way up to a 6 Degrees of Freedom headset like an HTC Vive or an Oculus Rift, you're able to experience this. Ubiquity and immediacy is what I was saying, from a physical location to a browser to the home screen to a headset. And all of this can be done in less than 30 seconds. Socialness, the web is social by nature. So, of course, all the frameworks and technologies that you're used to coding, you can use them in WebVR. And how we're enabling new creators in different areas. So the web has a lot of potential. VR has a lot of potential to enhance the web. But what I'm interested here in talking about is not specifically about VR on the web, but why don't we kind of like shift and we talk about the web on VR? Because there are plenty of ways that we are already seeing differentiators in this new kind of like paradigm. We can start talking, and we can see already the rise of new browsers like Samsung Internet for Gear VR, Chrome for Daydream, the Oculus browser, Super Medium. We have new workflows, and we have a new access. So if we're talking about new browsers, one of the ones that I mentioned, Samsung Internet for Gear VR. If we're talking about, and going back to this, one of the advantages that we have is that we can enable, these browsers enable spatial UI and spatial UX, and they can combine this with even providing, for example, JavaScript APIs that allow you to customize the background of the browser to something that's related to your experience. And if we can get the demo running, then I'm going to be showing that. New workflows, let's say that there's a lot of content, and there's a lot of ways that you can mix existing content with, let's say, new types of 360 images or 360 videos. So it would be cool if you're just browsing the web on your phone, you take your phone, you put it in a headset, it automatically detects that it's in VR mode, it switches, and then it switches back once you're done. Because we want to make the experience as frictionless as possible for the user. And finally, new access. And this screenshot is from a project that's being worked in Bulgaria by the Lens VR team, one of these new browsers that's been coming out. Interesting because it really begs the question, what about the semantics of depth in VR? And it's not only about talking how can we put different, let's say, DOM elements in space, but also how can we make the browsers be more compatible with new types of assets, like 360 media, like 3D models, etc. Now, the thing is that when we think about VR, we kind of have this image in our heads. And the problem with this image is that it assumes that the user has a 6 degrees of freedom headset. Basically, 6 degrees of freedom means that the device is going to be tracking orientation, it's going to be tracking position. So if you've actually used an HTC Vive or an Oculus Rift, you're going to see that you can actually duck, and your movement and position is going to be tracked. Same with hands. So that's the concept of 6 degrees of freedom. Now here, we're supposed to have an inline demo that, for obvious reasons, I'm going to prefer to move to the end. But basically, it's a web VR experience in which we have some of these new type of assets. So we're talking about 360 images, and we're allowing the user to browse some sort of gallery with this. You can see that you have two Minecraft-inspired hands. Actually, they're more inspired on the graphical theme of Amsterdam JS this year, which is pixels. And it's enabling, actually, let me show you here a video, because just in case the demo failed. So here you're seeing the web browser. In this case, it's Edge, and you're seeing the Windows mixed reality environment. You're going to see how when I click on the browser to go into VR, and this is something that's going to happen in Firefox, in Samsung Internet, and Chrome, it enables this tracking of the pose of the hands and the headset. Now, in this case, it's quite simple, and we can see here how we're looking at the beautiful cathedral in Reykjavik. And it works. It works. It's quite simple. You can move, you can stretch, you can grab things. It's what you would expect from VR. And it's the ideal case. But what we have to have in mind is that ideal is quite rare. And there's probably more low-end devices. And by low-end VR devices, I'm probably referring to Google Cardboards, Daydreams, and something like the Samsung Gear VR. There are more low-end devices out there, and people that actually have not tried VR than actual 6 degrees of freedom. And there are many people in the industry that believe that the future of VR is going to be definitely mobile, because you're not tethered, because it's less expensive, but that comes with some drawbacks. So it's important to actually know how can we start targeting these cases. And for this, it's important then to know what's the hardware support that we have on the browser. Let's start from the lowest type of VR that we can have to the highest type of VR, more or less. We have the concept of magic window. Magic window is when you have this is probably for phones, when you have, and actually I'm going to go back to this demo, because there's a URL. That URL, if you take your phones right now and you go to that URL, you're going to see how the magic window comes into effect. It's like a portal. It's like seeing into the web VR experience, and you can actually start engaging with the experience without even having a headset. So that's the concept of a magic window. Now, what comes after this, let's say you can enhance for a 3DOF, which if we said that 6 degrees of freedom, it's position And rotation, 3 degrees of freedom, it's only rotation. So in this case, we're talking about devices that have controllers that look like this. This only tracks rotation of my hand. If I take this control and I move it around, you're not going to be able to see that. 6 degrees of freedom. So in that case, we have controllers like these. You have 2 controllers, and you're actually detecting orientation, and you're actually detecting position as well. Controllers, and this is quite interesting because there are many experiences that do not rely on any of these, and we're going to probably see some of them in a bit. Other JavaScript interfaces that are not necessarily standards. Think about every single JavaScript interface that comes with the Leap Motion with Microsoft Connect. So technically, you could use a cardboard device to create full body VR experience, and that is quite interesting because you're using this concept of mix and match, and even the web speech API. So the basic idea here is that we need to adapt our content, and it's not really that different from what we've already been doing since the rise of the mobile web. Does this make sense? Does it make sense for me to start thinking about what happens if the user does not have 6 degrees of freedom controllers, for example? It kind of does, and we actually need to start doing it because I want you to take a look at the 2 devices that are right now on screen. One is the HTC Vive Focus, and the other one is the Lenovo Mirage Solo. Are they 6 degrees, 3 degrees of freedom? It turns out that they are kind of like a mix of both because they have a 6 degrees of freedom headset with a 3 degrees of freedom one-dish controller, but now they've actually announced, for example, HTC Vive, that they're going to allow to make this control behave like a 6 degrees of freedom controller. So we actually thought from the start in what would happen if we don't have access to the 2 controllers. Pretty much we would have this case already solved. And this is, again, what we've been doing. It's the concept of progressive enhancement. It's just in a whole new dimension, literally. Let's go and talk a bit about 3 degrees of freedom then. In 3 degrees of freedom, this is a video that I'm taking from the demo. I want you to notice how the browser itself is changing the background as well of the experience. Once I click on a link, it's loading now the page, and you can see how I'm not only being able to change the environment that the user is in, but now, once I go in immersive mode, I'm going to have not the 2 controllers, but I'm going to have just 1 controller. Now, in 1 controller, and with 3 degrees of freedom, I cannot track my position, so it's easier to start thinking about some sort of raycasting laser controls or some way that allows the user get to the content that he wants. So this is, again, it's a screenshot. I have all the demos, and they're actually working. It's just a bit hard to broadcast them. I have all the equipment, and I'm going to set it up afterwards if you're interested in trying some of these. But this is more or less how it would look. You see that I have the same hand, but in this case, I only have 1 hand, and it's not tracking the position. What if we actually take both controllers away? What are the options that we have if we take and we go into this, what's commonly called 0 degrees of freedom? If we need to laser or pinpoint something, then we can start thinking about raycasting, and you could do raycasting pretty much with the gaze, so you have the cursor, and based on that is what you're going to be targeting. You could be tapping, and that's, for example, what the magic window is generally using. You put a cursor and you tap on the screen. Once you tap on the screen, then that's the content that you're selecting. You could be using a desktop, and you can be using then your mouse. Click, you fire raycast, and that's the way that you would be interacting. What about mouse movement? You can use the pointer lock API to pretty much just have an infinite scrollable space where you can rotate the camera around if that's something that you would need. Keyboards. Well, we can pretty much just get the keyboard and use it in our experiences. And 2, which are the ones that I'm going to talk about because I think they're quite interesting for some scenarios, which are the gamepad and speech properly. And of course, this is going to vary from browser to browser, so it's a bit tricky, and so just make sure to do proper detection. And we start speaking about gamepads, and when we're talking about gamepads, we're talking about anything from a Bluetooth, standard Bluetooth controller to a wired controller, Xbox, PlayStation. Good thing is that there is a widespread support for these type of experiences, and you can see a lot of use cases where you might not want to have 6 degrees of freedom or 3 degrees of freedom. Actually, when the Oculus launched, or if you're actually playing Minecraft on an Oculus, you are playing it with a gamepad. You're not playing it with full motion controllers. And also, Super Lucky Sail on the Oculus platform. These are examples that we can mimic and connect the gamepad to the browser and just play around with this. Some of the annoyances, I would call. So at the moment, the specification is going through a lot of changes, and the gamepad API is the one that at the moment is being used to detect if you have one of these is being considered a gamepad, one of these is being considered a gamepad, one of these is being considered a gamepad. But the support is not the best. This is going to change for the upcoming WebXR API. Some of the difficulties that we have is, for example, detecting what type of controller in order to adjust the UI. So for example, if you have this controller and it's not moving, Firefox is going to report that it doesn't have orientation or position, while on the other hand, Microsoft Edge is going to say that it's a controller that actually supports orientation and supports position. So just be sure to do a lot of testing, especially when you're tackling a wide range of devices. There are other things that are a bit weird. Sometimes the gamepad API puts random things. In this case, this is my computer, and it's detecting the keyboard as a gamepad and some other unknown gamepads. So just be sure that you're getting the right gamepad. And as a rule of thumb, try to stick to the most important buttons in gamepads. We've actually tested from, let's say, a standard Xbox controller connected via Bluetooth. Actually, if you connect it via USB, you're going to get slightly different information on some parameters. But also, we've even tried the Nintendo Joy-Cons, and they actually work. We've managed to get kind of like a let's say, minimum set of mappings that work. So if you want to use the gamepad API, for some experiences, just remember that the most important buttons are going to be first in the button array of the gamepad object. This is how the Joy-Cons look connected to the Samsung Internet Browser. So there is support, and you can actually use them for experiences if you wanted to enable these type of experiences. This is another demo. Again, all the URLs are put here. So if you want to take your phone, go to the URL, then you can pretty much do it, and you're going to be experiencing this application. This one is built specifically to work with a keyboard and with a gamepad. And again, I'm going to have it after the presentation, so you can try it out. And now we're going to talk a little bit about speech. Speech, this is one of the complicated ones, basically because support has been changing, and actually this used to work in Chrome and in Samsung Internet a couple of months ago. There's been a change, and now it's not working. It's actually working on Chrome for desktop. But I think it's an interesting case to think about concepts of should we be thinking, now that we're trying to get many of the things that we have on the 2D web into an immersive web, would it make sense to start thinking about some type of variable dimension web components? And I created a basic example where if you put a web component that is just wrapping the web speech API, you can put it on a 2D web page, and you're going to get this button. While if you put it on a 3D immersive page, then you could be detecting, OK, there's a scene here. I'm going to get a 3D model of a microphone. I'm going to put it here. I'm going to animate it. I'm going to change it. So would it make sense to start thinking about these type of components for immersive web? Unfortunately, the support that the speech recognition API has, it's not really stellar. Nonetheless, if you think about cases like Cortana on Windows Mixed Reality, then it's something that's worth looking into, and it's definitely going to be supported in the future. So again, it's experimental technology, but you can already start playing around with this. So to summarize the information that I've been giving you, first, we think that the web is a suitable platform for immersive experiences, specifically because it can really democratize VR. You no longer need a headset or a high-end headset in order to start engaging with VR experiences. It can truly help the commoditization of VR for the same reasons. It can use a flexible OpenStack technology stack that we actually already know. If you're a web developer, then it's very easy for you to just jump into VR and start creating scenes, either with A-Frame, Babylon JS 3, or WebGL. And you can enable innovative experiences that are gravitating around all these concepts. And I don't want to give the idea that it's a bad idea to start developing immersive experiences, because while the new specification is coming, WebXR is coming, WebVR is already here, and you see that it has a broad support. WebVR 1.1 is here, and it's actually quite stable. I would actually recommend, if you're interested in starting to dig into the immersive nature, then start playing with it, because there's a wealth of content that can be enhanced through through XR technology. I think it's not just thinking about all the ways that you can create worlds, for example, but also think about how can you enable experiences that are going to enhance the existing web. And this is one of my favorite ones, because it really showcases the power that you have with WebXR. This is an example that was created by Diego and Kevin from the A-Frame team, and it's pretty much a mock-up of a Wikipedia page with information from the Burj Khalifa. The cool thing is that you have a web VR snippet underneath the picture, and you can just go in immersive mode, and it's just going to put you as if you were right beside the building. So it really gives you a sense of, whoa, this building is actually massive. We need to use the web to focus on UX and accessibility of the experiences that we create, basically with feature detection, and focus specifically on, again, progressive enhancement. Now, all the demos that I've mentioned, they were supposed to be in line with the presentations, but there's been a couple of problems, specifically streaming the content to you. So I've built all these demos. I'm probably going to set them up in the discussion corner. So if you're interested in knowing how they work, how the same experience would adapt to any of these devices, then please come and talk to me. And that's pretty much everything I have for you today. So thank you very much.